Welcome back to Math with Miss B, and today we're learning fractions, lesson style. A fraction is part of a whole number. If you ate half of a banana, a half of it will be left. If you ate a fourth of a banana, 3/4 of it will be left. Every fraction has a numerator and a denominator. They are separated from each other by a line referred to as a fraction bar. Fractions can be positive or negative. There are three types of fractions. There are proper fractions, improper fractions, and mixed numbers. When writing fractions, they should be written in their simplest or lowest terms. For example, let's take 2 divided by 4, or 2/4. 2/4 written in its simplest form will be 1/2. How do we do that? Well, first you want to determine the factors of each number in the fraction. So the factors of 2 are 1 and 2, meaning these two numbers, if you multiply them together, will bring back the number 2. And factors of 4 are 1, 2, and 4, meaning that 1 times 4 will bring back 4, and 2 times 2 will bring back 2. And since 2 is being multiplied by itself, we just write it down once. The common factors here are 1 and 2. Of the two common factors, the highest common factor is 2. So what we do, you would choose the highest common factor and divide each of the numbers involved in the fraction by 2. And if you divide 2 by 2, you will get 1. If you divide 4 by 2, you will get 2. So 2 by 4, or 2/4, or 2 divided by 4, will give you a fraction of 1/2. Let's try 8/10. 8/10, 8 by 10, or 8 divided by 10, should give us a lowest term of 4/5. How? First, we want to determine the factors of 8. Let's try this. So what you would do, you would say, well, 1 times 8, it always has 1. All the factors start with 1. So 1 times what will give you 8? So 1 times 8 will give you 8. And so 2 times 4, when we do 2 now, we're going to go down in the numbers. So 1 times what gives you 8? 8. So you put 8 on the end here. And usually you would have your factors with the smallest number at the beginning and the largest number at the end. So 8 right here. Then you look at the next number 2. 2 times what will give you 8? 4. So you would say 2 times 4. Now if you look at 3, 3 times what gives you 8? Nothing. Okay, if you go to 4, 4 times what gives you 8? 2, right? So we pretty much stop there, because 5, after 5 there's nothing. 6 times whatever gives you nothing. So your factors will be 1, 2, 4, and 8. So we can get rid of that big space. Okay, now we're gonna move on again. So we're gonna say 1 times what gives you 10? 1 times 10, so we put 10 on the outskirts right here. And then now we're moving on to number 2. 2 times what gives us 10? 5, so we put 5 out here. And we move on to 3. 3 times what gives you 10? Nothing. 4 times what gives you 10? Nothing. 5 times what gives you 10? 2. So we can close this gap up because we are done. Nothing else can give you 10. 6 times something, no. 7 times something, no. 8 times something, no. So we are done. So we're closing these gaps up. Now, if you look at it now, you can pick the common factors, and that would be 1 and 2. We can write the common factors here. And we have 1 and 2 as common factors, and the highest common factor is therefore 2 out of 1 and 2. hence, if we write back our numbers, we can say 8. We'll write it like 8, and I'll put a fraction bar here, and 10. And then using a blue color, that's 8 divided by 2, and 10 divided by 2. And that, of course, will give us 4/5, because 8 divided by 2 is 4, and 10 divided by 2 is 5. See? So we got 4/5. After a while, you'll be able to write these fractions into their simplest forms without doing all of this, right? You'll be able to do it without all of it, but it's good practice, and eventually you'll be able to say 8/10 is actually 4/5. You'll be able to do it in your head easily with good practice. Alright, so for a fraction to be proper, its numerator must be smaller than its denominator. So here we have 8/10, 2/5, and then we have a negative fraction, we have 4/11. So if you look at the numerator, you see that 8 is less than 10, 2 is less than 5, 4 is less than 11. So that's how you recognize a proper fraction. It's you could say it looks like a triangle in terms of you have the small part on top and the larger part on the bottom. Not that it looks, but in your mind you're thinking, well, the small part of a triangle, a regular triangle, if you draw it like this, would have, you know, this pointy part on top and then a broad base below. Because, you know, you could draw triangles differently, but this particular triangle, let's think of an ice cream cone. That's better to think of. So if you have an ice cream cone, you turn it upside down, so the small part is on top and the broad part is at the bottom. Similar to this, so you have a small number on top and a larger number at the bottom. Now when you add proper fractions with the same denominator, right, you simply just add the numerators, okay, and keep the denominator the same. So what you would do here, you would say, well, 1 plus 2/4. You'd never add the denominators, so you have a quarter plus 2/4, and that will give you 3/4. Okay, so when you add in proper fractions, make sure if you want to add straight, the denominators have to be the same number so you could add straight. So here again, the denominator here is 8, and you have the numerators being 5 and 2, so we add in right here 5 plus 2/8, and that will give us 7/8. Same idea here, 6 plus 1/10, that gives us 7/10, and then 3 plus 2/7, and that will give us 5/7. And these are perfect, it can't go down any further, so they stay as is, can't go down any further. Great. Now when you add proper fractions with different denominators, now you have to seek a denominator that is common to both fractions. Sometimes people look for the, you know, the lowest common multiple that's common to both, but to make your life easier, you just multiply each other by the other. So for instance, you have 2/6 plus 1/5. What I'm trying to say is that if you multiply 6 by 5, and if you multiply 5 by 6, you get 30. So AB is equal to BA. Same idea. 6 times 5 is equal to 5 times 6. So you're pretty good if you say 6 times 5, and whatever you do to the bottom, you need to do to the top. And then here now, if over here has a 6, we say 5 times 6, and then whatever you do to the bottom, you do to the top on the next side as well. Eventually you're going to end up with 2 plus 6, and the denominator will be 30. It will end up with 16/30. You find the common factors here. If you can't see it, if you can't bring it down to the simplest term, You look for the common factors and then you determine the highest common factor. And then from there, you will end up with 8 over 15. Okay? Now you know that this can go down because 16 and 30 are even numbers and they're large even numbers. So you can bring them down. So let's try this one. We have 2 over 3 plus 1 over 5. What do we do first? We look at the denominators and realize they are not the same. So if you were to write the answer is 3 over 8, you will get it incorrect. That is not the answer. So let's see how we can tackle this problem. So if 5 is over here, we multiply 3 by 5 and we do the same thing to the top. Let's not forget to do what we do to the bottom to the top, otherwise our answer will be incorrect. And since we have 3 over here, we'll say 5 times 3 and then we'll do to the top what we did to the bottom. Now 2 times 5 is 10 and 1 times 3 is 3. 3 times 5 is 15. Okay? And so your answer will be 13 over 15. Looking at this, I can see if we do if we do factors, you realize that they'll have nothing in common. So first of all, 13 is a prime number. So we have 1 and 13. 2 times something doesn't give you 13. So pretty much this is out. 15 is not a prime number. But we can see, 1 times 15 gives you 15. 2 times what gives you 15? Nothing. But 3 times 5 gives you 15. 4 times something doesn't give you 15, so it pretty much ends here. Anything common? No. The only thing that's common is 1. And so your answer stays as 13 over 15. Okay? Alright, so I hope you got this answer. Now subtracting proper fractions with the same denominator is pretty much the same as the addition part that we did earlier. So once the denominators are the same, we can proceed. So we just say 5 minus 1 over 6. And that will give us 4 over 6. Now 2 of these numbers are even. And so we could say, okay, we could divide by 2. Or we could look for the common factors. For me, in my head, I'd start dividing each number by 2 without looking for the common factors. If you like to look for the common factors, you can, and I can do it still. So 1 times 4 gives you 4. 2 times 2 gives you 4. And that's pretty much it, right? So I wouldn't put 2 again. So it's 1, 2, and 4. So I will get rid of that 4 on the edge there because we're making space for the extras. And so let's try 6 now. 1 times 6 gives you 6. 2 times 3 gives you 6. And 3 times 2 gives you 6. So we're pretty much done because 4 times what gives you 6? Nothing. 5 times what gives you 6? Nothing. If you look at this, you realize that the common factors are 1 and 2. So to get our fraction in its lowest term, we say 4 divided by 2. And 6 divided by 2. And so we know that 2 into 4 goes 2 times and 2 into 6 goes 3 times. So your answer will be 2/3. Let's try this one. See, the denominators are the same, so we could subtract the numerators. So we'd say 6 minus 9 over 10. And again, remember fractions can be negative. So we learned on the number line that if we subtract in if we say 6 minus 9 and we subtract in, we start on the positive side of the number line. So the positive side on the number line, so we have 0 right here, and then we have 1, 2, 3, 4, 5, 6. I think we're gonna run out of space. Yeah. So if we have 6 here, we say, let me try to do it properly. Remember, on the number line, you always move to the left when you subtract, and you always move to the right when you add. So for a quick tip, if you have a larger number, in terms of negative 9 is not larger than 6, but ignoring the sign that it has, you see that 9 is larger, your answer is going to be a negative number, and so you just subtract 6 from 9, and you will end up saying that you get negative 3 over 10. And to prove this, I will draw it on the number line for you down here. So we have 0, and we say 1, 2, 3, 4, 5, 6, and then we're going all the way. We're going to negative 2, negative 3, negative 4, negative 5. So this is saying 6, positive 6 minus 9 units. So if you're subtracting, you're moving to the left. So we say 6 minus 9, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer will be negative 3 over 10. Right? And like I said, if you want to do this quicker, you see 6 look like a smaller number and 9 is a larger number here, ignoring the sign. So therefore your answer will be negative, and then you would just say 9 minus 6, and that will give us 3. Eventually you're going to find your own pattern on how to do this, but that is what I did to save myself from the confusion and from having to draw a number line every time when I was in school. Okay, so now subtracting proper fractions with different denominators. Same idea, you need to find a common denominator. Here we have 5 6 subtracting 1/10, right? So you have a 6 here, you have a 10 here, multiply the 6 by the 10, and multiply 5 by 10, and multiply 10 by 6 and 1 by 6. So we end up with 50 minus 6 over 60. You end up with 44 over 60, and you look for the common factors. The common factors or common numbers end up being 1, 2, and 4, and the highest common factor will be 4. So you divide 44 by 4 and 60 by 4, you end up with 11/15. Okay, so let's try 4/5 minus a half. That shouldn't be bad. So if you look at this, you have 5 over here and 2 here. So we just multiply 5 by 2 and 4 by 2, and 2 by 5 and 1 by 5. So we're just multiplying each side by each other's denominators. Simple. So now you say 8 minus 5, because 4 times 2 is 8 and 1 times 5 is 5, divided by the common number, which is now 10. Now 8 subtract 5 units would be 3, remainder 10. If you look at this, these would have no common factors, because 1 times 3 is the prime number, you end up with 1 and 3, and 10 you will end up with 1 and 10, and then 2 and 5, and pretty much that's it. And the only common factor here will be 1. So your answer will be 3/10. Alright, converting proper fractions into decimals. So I'm just showing you the many ways fractions are used in maths. Right, so sometimes you will have a proper fraction. A proper fraction is just showing you, it's just a way of showing you how decimals could be written as well. And the money system that we use today is basically decimals. So a half of a dollar is actually 50 cents. So you could use that by, use money to tell you, this makes sense this way, right? So how do you do that? Well, you divide 1 by 2. So 2 into 1, 0 times. You add a 0 behind to the right of the 1, and you add a decimal place in place of that 0. And now you say, well, 2 into 10 goes 5 times. 5 times 2 is 10, and the answer will be, well, what's the fact will be 0. So your answer will be 0.5. Let's try 2/5. 5 into 2, 0 times. You place a 0 to the right of the 2, and you put a decimal in place of the 0. 5 into 20 now will go 4 times. 4 times 5 is 20, and that will give you 0. So 2/5 as a decimal is 0.4, and 1/2 is 0.5. Alright, so improper fractions have larger numerators than their denominators. For example, 8/3, this is a larger number sitting on top of a smaller number. 6/5, a larger number separated by a fraction by with a fraction by 5, and then you have -7/2, so a larger number sits on a smaller number. Now we can convert improper fractions to mixed numbers, right? So what you would do, you would look at the amount of times 3 can go into 8. If you look at 1, can 3 go into 8 once? Yes, but you want to go into 8 and then get the closest product to 8 without going over. You can go into 8 once, you can go into 8 twice, and have it like 6 twice right here, right? So 2 times 3 is 6, right? But can it go into 8 3 times? No, because then you would have more than what the numerator is. So we stay at 2, so you can go into 8 twice, and then we say, well, 2 times 3 will be 6, so we subtract 6 from 8 with a remainder of 2, and we have 2 and 2/3. We just put it back over the denominator that was there. Let's try this one. Well, 4 can go into 10 once. It can also go into 10 twice. If we say 4 times 1, that's 4. 4 times 2, that's 8. 4 times 3 is 12. So we have to stop at 2. So we say, well, 4 can go into 10 2 times. And that 2 times would be 8. So we have 8. So we said 10 minus 8 will give us 2. And so from there you have a remainder of 2, and you put it over 4. If you convert, you see that 4 times 2 is 8, and then 8 plus 2 will be 10 fourths. But we'll get to that soon, right? And so this will be our beautiful mixed number. Now, converting mixed numbers to improper fractions. Now, what we did a while ago was convert improper fractions to mixed numbers. And now we want to convert mixed numbers into improper fractions. First, we must note that improper fractions have a whole number to the left of a proper fraction. So this is how it looks. You have this whole number and then a proper fraction sitting to the right of it. Okay, so improper fractions have a whole number to the left of the proper fraction, or you could say the whole numbers have a proper fraction to the right of it, right? Either which way, you know that there is a whole number to the left of the proper fraction. There's a whole number to the left of the proper fraction. How do we change from mixed number to improper fractions? Well, it's not hard. Using the same numbers from the slide before. Step 1, you just multiply the denominator by the whole number, and then whatever answer you get, you add it to the numerator, and then just put it on above the fraction bar over the denominator that was there previously. So let's try this one. This one should be cool. Using the same idea, we would use step 1, we're going to multiply 4 by 8, and then step 2, whatever product we get, we're going to add it to 3. So step 1, 4 times 8. 4 times 8. And then step 2 now, we would set 32 plus 3. That will give us 35. Therefore, the improper fraction will be 35 over 4. Okay? So that's how you do it. It's simple. Now when we're multiplying fractions, pretty easy. First of all, we want to make our multiplication very simple. We don't want to multiply and end up with 30. 3 times 10 being 30 over 5 times 6, which is 30 as well. And that will give us 1. We want to start with small numbers. So we could go like this. We could say, well, 3 into 6 goes 2 times, and 5 into 10 goes 2 times. We end up with 2 over 2, and that will give us 1. Now note well, you can simplify your fractions going diagonally or going top to bottom. Okay, once there's no additional subtraction signs up in here and it's just a fraction bar and a multiplication sign, and it's just simple like that, you can break down your fractions accordingly and your answer will be the same. Same thing if you had 30 over 30 equal to 1. You could do it like that, but that's so many numbers to work with. Let's try this one. Again, here you could end up with 2 times 21 over 7 times 3. And you could say, well, this will give us 42 over 21. 21 into 42 goes in there twice. Or you could say, oh, well, you could see it here too, and you could do it here as well. You say, well, 7 goes into self 1, and 7 can go into 21 3 times. And on top here it says 3 can go into 3 once, and you get your answer, which is 2. You could even do it here. You could have said, well, 7 into 21 is 3, and 3 into 3 once, and your remainder would be 2. So your answer would be 2 without saying 42 over 21, right? Dividing fractions by fractions. Well, this one is not hard either. You just have to remember what to do. If you divide a fraction by a fraction, the fraction that is in the denominator has to be flipped, and then you will multiply it by the numerator. So here we go. So we have 3 over 5. You flip this fraction, meaning you will say it's now 5 over 6, and you multiply it by the numerator. If you look at it, you will see that 3 can go into 6 twice, and 5 into 5 once. So you end up with 1 over 2. Your answer will be a half. Let's try this one. Again, we have to flip this. Flip it, then multiply, and we have 2 over 7 times 21 over 4. Look for ways to make a fraction smaller. 7 into 21 goes 3 times, 1 into 4 goes twice, and you end up with an improper fraction, which is 3 over 2. And again, we'll look at how many times 2 can go into 3. And if you look at it, you'll see 2 times 1 equals 2. 2 times 2 equals 4. So we say that 2 can only go into 3 once, because after 2 times 2, once you reach 2 times 2, you get 4, which is greater than 3. So 2 can go into 3 once. And we would say, well, 3 minus 2 equals to 1. And so remainder 1 over 2. Okay? And your answer will be 1.5. Alright, I'd like to thank you for watching my lesson on fractions broken down. I hope this helps you a lot in class, and feel free to ask questions within reason. Alright, good night. Bye.